All right, here's the review on radical equations. So let's look at some examples. The steps, we are going to isolate the radical part. So if I look here at a step that we're going to do, I want to isolate the radical part. So I'm going to subtract 5. And then I'm going to square both sides to undo the square root sign. The square root and the square, they undo each other. It's just x. Negative 12 squared, that's 144. Now we have to make sure that works. So if I plug in 144, the square root of 144 is 12. And then 12 plus 5, does it work? And the answer is no. So that means this one is no solution. And that answer is extraneous. In fact, at this step where it said the square root of x equals negative 12, right there I would know there's no solution because the square root of a number can't be negative. Let's look at another example. Here we have a square root equaling a square root. So to solve this, we're going to square both sides to undo the square root. So we have 2x subtract 1 equaling 5x plus 5. Then I'm going to solve this by combining like terms. So I'm going to subtract 2x. I'm going to subtract 5. Oh, I think we're going to have a similar situation here. And then when I subtract 2x and I subtract 5, divide by 3, and x equals negative 2. Now, just because the answer is negative doesn't mean it's bad or not. We have to try it out. So if I plug negative 2 into the square root underneath the radical, 2 times negative 2 is negative 4. Subtract 1. The square root of a negative number is not defined. So this does not work, and again, there's no solution. I should do an example where there is a solution, right? Let's try one where there is a solution. Here we have a square root equation. It's already by itself equaling a number. It's equal to a positive number, so I feel good about this one. To undo a square root, we square both sides. That's x plus 5, and then 6 times 6 is 36. And then, to get x by itself, the inverse of adding 5 is to subtract 5. And the answer is positive 31. Now, how do I test that answer? You plugged 31 into there, solve it, and does it work? And it does. Done. Let's look at another example. How about one where you have to FOIL? Make sure it works. I think this will work. So here's one where you have to FOIL in order to work. So the square root's already by itself. It's equal to a binomial on the other side, an algebra. So when I square both sides to undo the square root, on the right side, I'm going to have to FOIL in order to solve it. So x minus 3 times x minus 3. I'm going to have to FOIL that. And then combine like terms. So we have x squared minus 6x plus 9. And now it's a quadratic equation. So now we're going to make it equal to 0. So I'm going to subtract x. I'm also going to subtract 3. So now it's equal to 0. And then I'm going to solve it. So we have x squared, negative 6, subtract 1 is negative 7. And then 9 take away 3, that's 6. At this step, I'm going to factor it. So two numbers that multiply to 6 and add to negative 7. So we find those two numbers. And then if I solve it, so if I take each factor equal to 0, one answer is 6 and the other answer is 1. Now, I have to go back to make sure that's a good answer. So if I plug 6 into here, 6 plus 3 is 9, and the square root of 9 is 3. 6 take away 3 is 3. It fits. That one works. But positive 1, what happens if you go back into here? So I'm going to write the equation over again. What happens when I plug positive 1 into here? Well, 1 plus 3 is 4, and the square root of 4 is 2. But how about on this side, when I plug 1 in, do you see that 1 subtract 3 is negative 2, and that they don't match, and that the square root can't equal a negative number? This is not a solution, and the only solution is positive 6. All right, Mr. G Math, over and out. I hope that helped.